Okay, then let's officially start this last webinar of 2024, December webinar, where you had option to vote for your favorite topics. And yes, let's go with my first slide, where we can actually see the survey on which you were able to select your favorite topic. We defined a bit more than 10 topics which could be interesting for you, and we can see here on the top side which were chosen at the end. And first, the most interesting was traditional orthophoto versus true orthophoto. So we will present this in a first batch. We'll try to explain you the differences, benefits, and all the deep knowledge we have about these two topics. Both of solution 3D survey supports, and you're able to decide to choose one in a specific scenario and another one in another specific scenario. So this is going to be the first one. Then Mattia will present you the integrated CAD tips and tricks in 3D survey. We all know this is one of the strongest parts of 3D survey software. So it's not just photogrammetry software. You have also a most powerful part of the CAD also inside, so you can extract lines, points, details also in the same software, and it's super useful. Mattia will spend a bit more time on this part. Then I will take over and try to explain you classification, which is kind of a mystery of 3D survey. Even we have sometimes issue to figure out what's better for some specific terrain and what's better for another one, but I will try to show you on examples how it goes and everything around. The fourth topic we will talk is LiDAR point cloud processing, so how to operate with LiDAR point clouds in 3D survey, some tips and tricks. Hopefully you get some ideas what's possible. We're definitely not going to be able to cover everything because we would like to finish this webinar in a 1 hour time frame. We have some additional webinars which were already recorded about the LiDARs, and we can navigate you also to this part. And last but not least, volume calculation, all possible scenarios. We all know this is the strongest technology that can cover volume calculations. If you have that kind of example, there is a no-brainer that you do it with photogrammetry and 3D survey because it's just the fastest, most accurate, and more visualized way to calculate the volumes and to visualize to your customers what kind of results you get on a field. And before we go to our first point, so traditional versus true orthophoto, I would like to ask Mattia to start the survey to get some feedback from you guys. So what kind of audience we have it here? So Mattia, feel free.
Yeah, sure. So we prepared some polls for you to get to know you a bit better. So if we start with the classic question, here, are you already a 3D survey user? So this one's quite simple. I guess I don't need more explanation. This should be an interesting webinar for both existing and not yet users. So just to get a feeling how much the percentage of existing users is here. So right now, 73% of you have already voted. Come on, let's squeeze a few more votes. Yes, it's almost 80 now. And yeah, 80% of you already voted, and it's looking like about 60% of you are already our users. Okay, let's close this vote. So 61% of you is already existing users and 39% not yet. So very nice. And let's continue to the second question, which is a bit more, well, did your favorite topic make it to the list? So you had 5 options to vote for. And we wanted to give everyone a chance, but as Marco presented the results, they were very close. Not every topic made it, of course. And let's see. We'll definitely, if this today goes well, try to do this again. But if a lot of you have missed your topic, we'll have to do that sooner rather than later. Okay, votes are coming in, and it looks like the vast majority of you got your topic. So let me wait just a couple of more votes. All right, last chance to press. All right, so 99% of you got your topic. So that's maybe one of you missed one. So sorry, you can comment in the comments what you missed and we'll take a consideration for the next time. And the final question to you, this one's a bit more complicated. How well do you understand the topics that you chose? So here we want to know, did you choose these topics because you know them very well, or is it the other way around? You chose the topics because you don't really know them and you want to get to know them better. So it's 1 to 5. 1 means that you know them very well, that you are an expert on the subject, and 5 is not at all. So something completely new, but something that you would like to know more about. And obviously these results are a bit more interesting because now we have 5 options, and 69% of you voted so far. Come on, let's go. Just a bit more.
Go. Okay, but we already have some results. So we are somewhere in between.
Yeah.
So you know quite something, but not too much. So, but you are also not a beginners here. So very good.
Yeah, almost Gaussian
Graph
curve
or something like that. Yeah.
But the majority of you answered on the side that you do know something about the topics. So, but the most popular answer was number 3. So somewhat familiar with the topics and you would like to know more about them. So I think it's best that we start. Marco, ready to take us to the world of orthophotos.
Thank you, Matthias, for heating us up. So let's start with our point number 1, traditional versus true orthophoto. For me, actually a super important point that you understand this part because we are still a photogrammetry software, and it's great to understand this because you can then perform also better on a project. Again, just a kind reminder, if there are some questions, feel free to shoot them in the question box. Don't forget it, okay? Use this opportunity. And otherwise, I will start my first presentation, first point, so traditional versus true orthophoto. So I try to emphasize first that you need to understand, so what's the big difference? And the big difference is that traditional orthophoto is calculated based on digital terrain models. So we do the classification, we eliminate all the houses, buildings, poles, everything out. So we just have a terrain point. With the point cloud, we calculate the digital terrain model, and then we do the projection of the drone images or any airborne images on the terrain model. And that's why I try to emphasize this here with a left picture on your screen, so the flat picture where the orthophoto is on, so that you remember always traditional orthophoto is where no buildings are as a models on and everything like that. So it's calculated based on digital terrain model. Opposite side, the true orthophoto is calculated based on 3D model, which we call a textured full 3D mesh. So this is a triangulated surface with the buildings, with all the details which are pointing out of the surface, and then we put texture on this model. It's a fully different calculation, has some benefits, but also some cons in comparison to the traditional orthophoto. But remember please this, so traditional is calculated based on the digital terrain model, true orthophoto is with buildings and everything like that. Okay, and now if we go first traditional orthophoto and see the advantages and disadvantages, we can quickly collect them here. So first I would like to go with the left side with advantages. So the traditional orthophoto is suitable for large areas. So if you have big areas, the complete, I don't know, village or a big construction site, or let's say a big rural area,
a long road,
low growth or anything like that, is the best case example to do it with traditional orthophoto. It's a pretty fast calculation because you need a point cloud, you don't need a full 3D mesh, which takes additional time, and it's also pretty power consuming. So the calculation is it's simpler because of simple algorithms. Third point already, the benefit, it's less hardware demanding. So if you have 3000 image projects or something like that, full 3D mesh, it's kind of hard to calculate it. You probably need to split it in small parts or something like that. But with the traditional orthophoto, you can cover it. Then in traditional orthophoto, yes, you have option to replace an image. So it's a simple feature in 3Dsurvey. For example, if you have road with cars, you can simply select the car areas and replace it with another image, because the moving objects are always on a different location and you can easily replace this part. And the last but not least benefit, the traditional orthophoto give you actually the maximum detail from the input images. So what does it mean? What does it mean? Actually, because the algorithms are simpler, the surface is more flat. When we do the calculation image on a surface, the pixels are nicely visible. So actually, what kind of the image input goes in the calculation, in the orthophoto, you get the same resolution, the same quality. So let's say no artifacts. I will show you this later on a real case example. So we would say you get the maximum detail from the input images with traditional orthophoto. And this is kind of super important if you need to extract out data like end of the road, or I don't know, the center white painted stripes or anything like that, or manholes, so you get really good visibility. But nevertheless, traditional orthophoto has also some disadvantages, and those are: at least one image must cover or contain the entire object for best results. So this is mainly going if you have buildings on or bigger halls or anything like that. So if you are able to capture images in this way, that the complete house is on a single image, then the traditional orthophoto will at the end also look nice. Otherwise, you will also have some blurry passes where two images are glued together. Okay, so this is the first negative aspect. Then the second one, on traditional orthophoto, roofs and objects which are pointing out from the surface are not on the correct coordinates. Okay, so this is super important to know. So if you calculate the traditional orthophoto with digital terrain model and you do the vectorization on the roofs in 2D, this is not a good approach, okay? Because roof is definitely not on the right spot. This is the minus of traditional orthophoto. And then the third disadvantages, you need to have nadir images. So where the camera is pointing perfectly down, usually you get this with a single grid mission, which is the most effective way for mapping. You can easily cover large areas, but in case you did a double grid mission with a 45 degrees camera and you would try to calculate traditional orthophoto, this is not going to work, okay? Because the orthophoto will look like mess. So definitely you need to have nadir images to calculate traditional orthophoto. If you did a mapping with nadir images plus oblique images, so side images also, then before you calculate the traditional orthophoto, just deselect the oblique images and you will get a nice traditional orthophoto. I will also show you this later on my example. Okay, so much about traditional orthophoto. There are some questions. Feel free to write them in question box, and I will switch to my second orthophoto, true orthophoto. And again, we have some advantages and disadvantages. And advantages of true orthophotos are roof and all other objects are on the correct coordinates. So this is one of the most important one. So if you like to vectorize out the roof positions or objects which are pointing out from the terrain model from the orthophoto, use a true orthophoto because they are on the right coordinates. Then the second benefit, it's a fully automatic workflow. So if you calculate true orthophoto, you can import images, use our batch processing, and from image to orthophoto, you don't need any interactions because you don't need to do the classification in between, which is a manual step. And with the true orthophoto, it just fully automatically everything.
Remember, we just talked about this one on the previous webinar, so you can check that out.
Exactly. Thank you, Mattia. So then the third strong point, when you have the full 3D model with all nice facade and nice 3D objects, you can easily produce also custom plate or sign orthophoto. So if you have details from the facade, you can turn the bounding box for the side orthophoto and produce a custom plane or side orthophoto. And another benefit, so the true orthophoto supports nadir and oblique images. So even if you have some side images, nadir images and everything together, this is actually perfect for true orthophoto. And in this case, it delivers also the best possible results. We also have few disadvantages for the true orthophoto. And the one is so-called artifacts. So like bulked edges or trees, and this depends actually on mesh quality. So the better the 3D model is, the better the true orthophoto is. But nevertheless, if you zoom in an orthophoto, you will always have a bit better how to say, not just resolution, but visibility with a traditional orthophoto in comparison of true orthophoto. Because algorithm for true orthophoto is more complicated, we need a full 3D mesh and so on. This is kind of a bit of minus for true orthophoto. And the second one, it's to calculate the true orthophoto is more time consuming, it takes longer time. Beside the point cloud, you also need full textured, full 3D mesh. And if you have big data sets, 3,000 plus images, you need a powerful machine that it can take much longer in comparison to the traditional orthophoto. Okay. And as a conclusion with this topic are our guidelines when to use and what's important. So when to use traditional orthophoto or when to use a true orthophoto. And I will go with these general rules. So traditional orthophoto, if you have rural areas, so where fields are, where stockpiles are, where roads are, highways, less buildings, smaller buildings, or something like that, the perfect option is traditional orthophoto. If you have large areas when you can cover few, I don't know, few villages, or let's say even a city or something like that, and you can fly higher, use traditional orthophoto. If you have linear objects like road, highways, railroads, cycling roads, rivers, again, the traditional orthophoto is good enough. And also for stockpiles or open pit mines. So where you don't have some kind of specific buildings, objects, or anything like that, where the terrain is more important for you, the traditional orthophoto covers this very nicely. And what's important with this one? So again, remember, you need to fly for traditional orthophoto, a single grid mission with nadir images, so camera needs to point top down. In a DJI, I think it's a minus 90 degrees or something like that. And in case you have oblique images also from the side, definitely deselect them before you go and calculate traditional orthophoto. Just leave the top-down images. You can do this in an image tab. There is a function to do it, and that's it. And the second important point with traditional orthophoto, fly as high as possible. We recommend between 80 to 150 meters above AGL. Why this is important? The higher you fly, the more orthogonal your image is. So the effect of the side turn of the building will become less important. Okay, so higher you fly, more orthogonal images, more area you cover with a single image. Remember, if you like to get nice traditional orthophoto, you need to get complete building on a single image, otherwise it's not going to look nice. And with flying height on 80 meters with the most standard drone, you can cover, let's say, a 2 centimeter resolution of orthophoto. If you have like P1 camera from DJI, so I think it's on 120 meter or 130 meter 2 centimeter resolution or something like that. And in most use cases, this is more than enough. Okay, very good. This was traditional orthophoto. The next one is true orthophoto. We warmly advise you to use the true orthophoto approach in case you are flying urban area and city centers where mainly high buildings are, big halls, anything like that. So definitely with the traditional orthophoto, you're going to get much worse results in comparison to true orthophoto in this case. Then the second location where we would advise you to do is industrial areas with big holes and long objects. You can cover really nicely this with true orthophoto with minimum artifacts, and of course construction site will buildings. If you already have on a construction site some concrete walls or everything like that, and this is important for you, do the true orthophoto. Okay. So hopefully you get an idea where to use which and what. And what's important for true orthophoto, you need to fly double grid with oblique images. So just remember, the better 3D model, the better true orthophoto is. So make as much images that you can from a different perspective, different positions to get the most beautiful full 3D model, and then parallel, you will also get a nice true orthophoto. And because you are always pointing camera in 45 or 50 camera degree angle, we advise you to fly a bit lower in comparison to the traditional orthophoto. So we would recommend flying height between 40 to 80 meter AGL, that you have more detail in a photo, because if you assume when you point camera down, it's actually 80 meter, when you turn camera a bit up, it's 80 meter flight, 150 of 120 meters or something like that. So that's why fly lower and capture images. Okay, this was with the PowerPoint presentation. I also have a few quick examples to share it with you. Just a second.
Yes, show us some 3D models, Marco.
Okay, so let's go with the video. Here I would like to show you, so a traditional orthophoto example, nice single grid flight with a perpendicular top-down camera, I think 2,500 images with Metris 350 or something like that, and P1 camera. You see, we fly a single grid mission. Actually, this is from one of our customers. Thank you for sharing this with us. And calculating orthophotos, classification. Here we can see the digital terrain model, so no buildings inside, just pure terrain. And If we go to the, okay, let's expect in a bit in addition. And if we go to the orthophoto and zoom in inside, because here was actually a flying height 120 or 150 meters, actually a lot of information will cover it in a single image. And that's why the most problematic areas on hose areas, hole areas, everything like that looks actually really good with minimum artifacts. Here we can see the cars on the road. We could use the recalculation option and eliminate those ones. Now I would like to focus on a bit more problematic areas. So here you can see the object is not perfectly perpendicular. It's a bit from the side. We see the bit of the facade on, but nevertheless, this is kind of rural area with not too many big buildings. Okay, we have some holes here, and this kind of area could be perfect for traditional orthophoto. Here we can see again some mistakes because of the high building, but we blur the orthophoto nicely together. Another hard detail, so big hole, but in this example, it's actually better than I thought. This is mainly because we fly high enough in this case. But nevertheless, you can see the resolution is almost perfect. It's the same to the resolution. It's the same to the resolution of image. And for that kind of areas, this is kind of a perfect approach for the traditional orthophoto. Okay. Let me now share my screen again with you. Zupan, can you see my screen? Can you just confirm it?
Yes.
Okay, okay, very good. So now I would like to show you another nice example for true orthophoto. So the second option of orthophoto. In this case, we need to fly this in a double grid mission or oblique mission in a DJI flying path planner. And you see we have a lot of side images which are pointing in the center of the object, a lot of buildings on our area of interest. I assume the traditional orthophoto would not be successful here. And if I go and switch to the orthophoto, here you can see now the roof positions are actually on the right spots. What's the bit problematic part a bit with not the perfect 3D mesh? We also have some artifacts close to the roof edges. Of course, we are also working on that to improve it in the next versions and so on. But nevertheless, it's still much better in case you use the traditional orthophoto here. So this is my second example that you can have idea. And then I have additionally prepare you additional true orthophoto with our favorite example. And if I go here to orthophoto, I actually have both of them on. So now I select the traditional orthophoto. The problem of, sorry, let's do it like so. The problem of this example was I was flying pretty low. So I didn't fly on 80 meters. I fly here actually on 40 meters. And I have here a big long object. And of course, the complete object is not on actually on a single image. So as you can see it here, my single image doesn't cover the complete object here. And then when we blend those things together, we get that kind of effect with traditional orthophoto. That's why we recommend you, if you are in city centers, use the true orthophoto. You get the position of the roof on the right location. And the complete building is nice. So if, and actually the roof is on the right position. So if I compare this with traditional one, you see, so this is the wrong position of the roof. This is the right position of the roof. And again, here maybe even more visible. So this is the traditional orthophoto. This is true orthophoto. traditional orthophoto, true orthophoto. And the higher are the buildings, the more visible is this effect. Okay, here even more maybe. Okay, even here where we have walls, you see, this is not perfectly perpendicular, this is perfectly perpendicular. But with the traditional orthophoto, instead you get maybe a better resolution. So if I focus here on a manhole details, okay, here is actually true orthophoto better, not sure why, shouldn't be. So this is the true orthophoto, this is the traditional orthophoto. So maybe you can see a bit more from the traditional here. And just to remember, where you decide where you find the traditional and true orthophoto. So after you go to the orthophoto, calculate top down, you see here written if this mesh, this source gives you a true orthophoto or gives you traditional orthophoto. Okay, so in practice, if you have as a mesh a regular grid mesh, we will suggest you actually a traditional orthophoto. If you have a full 3D mesh, the 3Dsurvey will suggest you here true orthophoto. Okay, I spent quite a lot of time for explaining this. Mattia, would you like to add something, or can we go?
Yes. Let me share another of mine example, if
Okay.
may. So I also have an example that compares the two orthophoto modes. So yes, here it is. This is the let me just put this away. Okay. Sorry. So this is the true and traditional orthophoto. There's a couple of advantages of traditional orthophoto here. Because the traditional orthophoto is built on a mesh on the DSM, as Marco mentioned, it will cover the area that the DSM is covering. So sometimes, usually where there's some vegetation, a point cloud can be quite sparse, and as a result, so can the full 3D mesh. And in such cases, traditional orthophoto can perform better. If you look at this road here, on true orthophoto, it got cut off because the point cloud here was too sparse and full 3D mesh was not generated well enough. This is on the edge of our case, so it's not really that important, but nonetheless, this can be a bit of an issue sometimes. The other thing where traditional orthophoto is better is if we zoom in on these trees, they don't look so good in the true orthophoto, but now I will turn on the traditional one and we'll be able to see these nice canopies and all the branches, everything in detail. It gets problematic when you see some sort of cables like this, because as Marco mentioned, stuff on height is not on the right. It's not on the right position. So this is one thing, and the other thing that I would like to explain here is the recalculate tool. So as you heard, when you are able to capture a whole house or an object on one image, you can also use traditional orthophoto for houses. You can see here, this isn't perfect. That's because this house is comprised out of two images. Now I can simply repair this issue, but that's only on the traditional orthophoto. So I have my traditional orthophoto, select the area of the house, and software will automatically offer the substitute image, and I will choose this one where this house is nicely visible on one image. I confirm, and all I have to do now is recalculate orthophoto with this button and observe this image is replaced now. The whole orthophoto image will be stitched together once again. Well, just the blending between this image and the neighboring image. This is taking a bit longer than expected. Should be done soon.
What's important also here is that you actually select a bit of buffer zone around the buildings, as Mattia did.
Yeah. So now you can see these perfect edges of the roof. It may not be on the exact right coordinates because it's still on the height of the terrain, not on the actual height of the roof, but it looks nice. If you only need an image, that's what you can do. So that's my part on the orthophotos.
Very good, Matthias. So now feel free to continue with the with the integrated CAD tips and tricks. So
sure. The second topic of today's webinar is integrated CAD module and some quick tips and tricks that we prepared for you. I have, as an introduction, a pre-recorded video for you, so I'll just roll it now. I'll turn off my camera so there's a bit more space.
We know that CAD module is one of the most appreciated features of 3Dsurvey software. And this is why today we are looking into some tips and tricks to make your work easier and faster. Did you know there's a quick way to add or delete a vertex when drawing a polyline? To add a point, select Edit tool and then simply double-click anywhere on the line. To remove the last vertex, press Backspace.
Okay, that was really quick. And I have another video with a perhaps of a combination of features. This will be a CAD module in combination with profile line tool. So let me just start this example video. Here we are monitoring a landslide area and we want to map the drainway of water. So in CAD module, we can just simply draw a polyline where we assume that the water will flow. But to inspect it in detail, what we can do is a profile line with perpendicular profile lines. And on those, we can choose the lowest point for each one of them. And as we go through, we can check if we picked the correct spot. So meaning that the center line is aligned with the lowest point. And as we check those perpendicular profile lines, we place a point on each one of them. And we go back into the CAD, and now we can see where we were off. So what we can do now is just connect those points that we created in the profile tool, and we'll have the correct lowest point path downhill. So here I'm connecting those points. And as I finish, I will have a new line which represents the flow pattern a lot better, like this.
So it's kind of good combination, helping you to extract with the help of the profiles some CAD details. So
yes, exactly.
You could do also for curb or anything like that. So something like that.
Yeah, that was just an example. You could also do the highest point, or if you have some anomalies on the profile lines, you can always add a point on them and look at that point in the CAD tab in the 3D. So now I will switch to screen now. So this one, I hope you see the right one. Yeah.
Okay, perfectly. We can see it.
Okay, here I want to show you some of additional or maybe more advanced things you can do in CAD, or maybe they're not advanced and some people just don't know about them. So one of them is, for example, the drawing on images feature. So if I create a new layer here in our CAD module, give it a color and some line width, and when I start drawing here, let's say here, this helper with drawing on images will pop up automatically. What it does is it helps me to reposition my points that were placed on either point cloud or 3D mesh. And if I'm really sloppy, I can place them on multiple images, and as I turn around, this images list will try to adapt to an angle that I'm viewing my 3D model from. And so I can reposition every point in multiple images to get the highest possible accuracy. Okay, but I guess you already knew that. So what you maybe did not know is that we also have a right-click possibility here. And there are a few commands. So the first one is delete this observation. What this means is you will simply delete the latest correction you made on this very image. So if you made multiple corrections, like on this one and here, you can just delete this one, or you could also delete all observation for these points, and it will delete also the second one. That's pretty self-explanatory, I guess. So there's one other option. Perhaps I want to place this point here on this thing that I'm not sure what it is actually. And as I turn around, I get an image of this thing. I say, okay, place it exactly here. And then I see, okay, I have a very much better image of this here. So I will reposition it on this good image. What I can do now is delete other observations for this point, because I know this one is the most accurate. And you can see only this one is left, and my position now is most precise. So, okay, and then there is one last option here. For example, if I do this, confirm position and delete all observations for this point. This one comes handy when you're working on some maybe not such a good data set and you want to just quickly reposition a point to a location, approximately correct location, and then you confirm that location with this, and then you start your reprocessing again to get to a higher level of accuracy. That's really an advanced scenario, but I guess not many people knew about it or what it actually does. So just to let you know, maybe you sometimes get into a situation where you may need this one.
And if you like to be super precise like surveyors are.
Yeah. Okay, so to finish off with the CAD, I would just like to go quickly over some of the features that we find quite nice, but we often see that our users are not so familiar with. So one of them is, for example, this point on vertex checkbox. What this does is pretty simple. If you're, for example, drawing a line, it will every time you click, place also a point on your vertex. So even, let's finish some line here. Even when you then later, for example, delete the line, the points will remain. So you knew exactly where your line was. And what's more, you could also use it like this. Maybe this is our road layer, and we would like to use it for curb. It's like sort of sub-layer thing. You can give it a code. So every point now that I draw with this tool will inherit this curb code. You see? And if I want to do, for example, a line, I can just write line here, and we can do like this, points that have the line code in their name. That is. And you can also uncheck the height if that's not important for you.
What about text size? Everything is so small. Can we set a bigger text size?
Oh, yes, of course. So, for example, if you want to do it for all the points, you have some possibilities. So let's choose just one. And now we can say select similar on the same layer. And now all of them are selected. And I just find the text size or font size here and increase it to, let's say, 16. And this is much more visible.
So you have
this
you
way
have select on similar layers. Very good. So this selection is pretty useful.
Yeah, selection is right here. If you didn't know, this down arrow has some additional options. We try to be as close to AutoCAD as possible. So if you're familiar with that, you should be right at home with this one. And perhaps the final thing, maybe sometimes you're working with some areas and you misplace your last vertex. What you can do is select your polyline, and there's an attribute closed. You can just set it to yes, and it will automatically connect it, and you see you got this area selected now. So before the area was not calculated, but now it is. It's right here. Maybe Marco, do you want to share the thing about saving CAD layers?
Yes. So a lot of surveyors or construction site companies, they're used to have some standard layer types for their projects. And there's also a hack to have this in 3Dsurvey. So actually, if you like to have some specific layer list, you can create it first time, save it as a DXF, the same way you would save this CAD data, and next time you just import them like a load CAD data, and the list of layers are automatically predefined. So I think Matthias is already working on this task.
Maybe something like that. You can also save the some of the properties. So you have this standard 4 or 5 layers, and now that they're empty, you know, I can save them without any real consequence, and I will have the let's say template, and this I can also omit the default. And every time I start a project, I can now, the first thing, just load CAD and use my template, and I will have this list of CAD layers, the same for every project.
So to save and load data, you just need to go under the data, save CAD as, and you save as a DXF, or you would like to load any cadastral measurements or anything else, data, load CAD, and that's it. We had one questions and I tried to answer it during the webinar.
Okay,
There are a lot
okay.
of interesting questions already, but let's wait till the end.
Yeah. Okay, let's move forward so we don't end up into our webinar.
Okay, yeah, time is passing quickly by. Let's take over. I would like to share my screen now with you. Just a second, make a presenter. I will share my screen. Hopefully you can see it right now. Okay, so Matthias shows you the integrated CAP tips and tricks, probably a part of it. Millions of there are in additions, a lot of webinars, tutorials. If you have questions, please feel free to write it. And we are moving to the next topic. So it's the classification, explanation of the parameters. I will try to do this based on a real case to explain you. First, nevertheless, we prepared a special document for you. So if you go under the resources, downloads, and you scroll down here, fully down, you have here advanced classification parameters guide, and you get kind of description of the specific parameters, what they means. To better understand the 3Dsurvey classification, I wouldn't spend now too much time for explaining them so specifically. I would explain you on a real case how it works, okay, to be effective with this. And I will share my next project with you. So it's a kind of a stockpile where we are calculating volumes. And before you calculate the volumes, we usually need to classify the terrain to eliminate the machinery, buildings, trees, vegetation, everything like that. And here on the right side of the tools, there is a classification button. I will click the classification, and now the second pop-up will come out. Okay, few more seconds. And we will see here the basic parameters for classification. And I would like to emphasize it, those parameters are good enough for 95% of the projects. If you have standard ones, I would just suggest you to leave it as they are and click on next to confirm them. Now the classification is ready. What you need to do, you need to show at least 1 point to help the software to find the terrain point, and then based on this, the classification is starting to work. Sometimes you need to pick 3, 5, or even 10 point. If they're running some cables over it, you need to decide, you need to click on the both sides of the cables because it just affects on the classification. And when you go to the next step, you get the classification result immediately here, okay? Right now, what you can click finish or you can cancel it. I will click finish for now to show you the result in the main window. So all red colors are classified point clouds of terrain. On the right side, you also see now 3 different classes: never classified, unassigned, and ground. Let's deselect this, unassigned also, and now this is our classification with the basic parameters. It's kind of good, but definitely I lost kind of details. I would like to have it if I'm calculating volumes, because I would like to have the top of the stockpiles here, here, and here. You see all those black holes are actually still stockpiles. So what can I do it now? I have here 2 options. The first option is I continue manual way, which is kind of super effective if you are in an area like this, or I don't know, if in a stockpile, some mines or anything like that, where you don't have some vegetation or maybe minimum objects like machinery or something like that. The manual approach, so automatic classification with manual approach, in this case is not that bad. I would like to show you how to improve it. So I turn on the unassigned class on, and I can see here clearly see what terrain is and what vegetation is. And I can manually now select parts I would like to add it also to the ground class. I need to be careful more here, where I have a lot of machineries also in my classification results. Definitely I would spend here 1 to 5 minutes, depends how complicated the selection is, but let's not spending too much time on this. Let's show you the approach. So you select the important point for you, then right mouse click on the ground and the option comes set this class to selected points. And after I click that, I actually move those points also to the ground points. And let me show you now the result of the ground point. You see, now we have perfectly selected ground points here, no holes inside. With a bit of manual interaction, I achieve good results. Okay, so this is one option, the A option. The B option, when this is more complicated, I go and try with the classification parameters, to play with the classification parameters. Unfortunately, I need to load in the project again because I would like to start from the beginning, from the raw data, to show you in a real case how it works. So let's wait 25 seconds to load in this project again. And now I will start the classification again and try to change the parameters a bit and try to explain you how this affect on the scenarios like that. And I think in most cases you have similar scenarios like here, and this can cover nicely the most of the cases. Okay, few more seconds. Let's go to the point cloud. The classification is running on point cloud. Start the classification again. So we start really from scratch, no previous input from the classification. My laptop is heating up probably. A lot of work to show today, but we manage. Okay, and now what can I do to improve this basic classification? I will focus in those three parameters. So the first one is regular grid mesh cell size. So with the classification, we are helping us with the surfaces. And more detailed surface we have, the better classification can go with these minimum details like the top of the stockpiles. That's why I will lower this one from 0.5 to 0.2. This can affect the processing step. If we have really large area, this is kind of a hard calculation. So it probably takes quite a lot of time and you will need a lot of memory. But in my case, I can try this one. Smoothing factor, I will put to 0. So my surface should be as sharp as possible, no smoothing, okay? Because it needs to align to the basic points. And then we are playing here with parameters, how far those points should be away from the surface. So it means 8 centimeters. If I extend these parameters, I will get more of the stockpiles. But from the other side, there is a danger that more vegetation will be inside, or maybe a smaller part of the rubber from the truck or something like that. But let's see what I get with this one. Okay, next. Couple of more seconds. Based on the classification, again, I need to click one point to show you the terrain point to the software to helping out. Click on the terrain where you're 100% sure that this is terrain. Don't click on a tree or on a house or anything like that. And even from here, I can see here in the center, the result is fully different. I will click on finish. And let's wait for my 3 classes. Let's unassign never classified and unassign off just to see the ground classification result. Here it is. And we can see I perfectly get my automatically stockpiles inside. Let's double check here the truck area. Also the result is not that bad. Maybe I get here from the front part some not so good points. You can see it here. Okay, so I would remove those manually. Let's check here the vegetation area. We eliminate some of them, but as I assume a bit more, I get a bit more vegetation. But if this is not important part for me, I'm satisfied. okay? And in this case, I managed to get my stockpiles perfectly with a minimal tweak of the parameters. And the same way it goes for the other examples, okay? So try to play with those three to see how it goes. Every time when you calculate the classification, we reset the parameters. So if you set some crazy parameters inside, next time will be at default, so no worries, okay? And then is another example here where our classification is super strongest, and this is actually in case, let me just see if I have this project. So in case you have actually a drone LiDAR, so not a photogrammetry point cloud, but a point cloud capture with the drone LiDAR. With the drone LiDAR, you have this option that you get also in a high dense vegetation, some terrain points. And not sure if you saw it before, we have their option, use the lower point or something like that in the classification parameters. And in the case you're using drone LiDAR, you should select this one. Let's wait to open the drone LiDAR project to show you this example, how this looks like. Mattia, any questions in between, or did I forget something? Would you like to add here?
Questions are popping up slowly and steadily. Maybe one thing also to note is the option to classify LiDAR point clouds.
Okay, so
also very
this
more
one is
pop.
right now popping up. This one is right now popping up. Okay, let's see the LiDAR point cloud. So this is from the drone LiDAR. I think it's a StoneX LiDAR or something like that. So we have a lot of trees. We have also some terrain. And if I go here with the classification, guys, today's webinar, it will take a bit longer than expected, but yes, let's keep on doing good job. Hopefully you have still some time. Otherwise, the recording is ready for you for everything else. Okay, so again, classification parameters. With the drone LiDAR, leave them as they are by default, but please turn off this one, point cloud from laser scanner. This means we can snap on the lowest point, and when I go to the next, again, the approach is fully the same. I need to show few terrain points to my area of interest, so I'm sure the terrain point is here. So I click my first time, I will rotate it like so, try to find terrain also here. It looks a bit crazy here because also trees are selected, but this is just because we have a lot of points on the same height. So the algorithm is stepping up and down and so on. But nevertheless, so I select few of them. When you go to the next step, the picture will be fully different. So this lower point really helps us. So I think we managed to select most of the points from the surface. And when I go into the finish, and I get my three classes on the right side. Let's turn off never classified. Let's turn off unassigned. And we see we get actually quite a lot of terrain points from the terrain in between dense forests. So, and if I go and calculate quickly the regular grid mesh, you will see it's more than enough to define the surface out from this one. Okay. Okay,
looks great.
This classification, additional explanation on our web page.
Yes,
this was
actually
our third topic. We close it down. I think Mattia is already ready for LiDAR point cloud processing.
We should continue to catch up. I have prepared two videos for this one. Let me just change this one. The first one, okay. In this video, I will show you a bit of a different approach that we're used to in 3Dsurvey. This is a case where you need no other equipment but just 3D survey. So I guess some of you are also working without scanners or without drones. That's not our typical users, but we also got you covered. So here we download the national LiDAR point clouds that are available in Slovenia. Many European countries do support this option. We just import them into 3Dsurvey, and now we will see them pop up. They are pre-classified, so they have buildings and vegetation on 3 levels and ground, and they look like this. So this is our castle hill, and we can do some of the visualization filters. So you can view height map, or this is the bounce return data visualization. So you can see in the forested areas there are more rebounds, and this is the height map. First of all, I want to merge these point clouds so I can work on them as they are just one point cloud. And now I will deselect some of the classes, because let's say I want to do a physical 3D model of this city. So I want to print out this in a 3D printer, or I want to make a ground level with buildings. So I just leave these classes on. And now I will calculate a DSM. Grid cell size is 0.5 meter, and I leave on the hole filling because there are some holes because I unchecked some of the classes. Now this is our 3D model of our capital with a castle hill and a castle on top. You can see the pathways leading up there. And what if I was tasked to produce a 3D model of a new castle model? So, for example, our mayor asked us to tear down the old castle and build a new one, and he wants to know how that would look like. I can, for example, first flatten the old castle. I select it, and there's a flatten command right over there, and our castle is gone. Okay, and now what I will do, I will just load the new one, and because it was done in a third-party software, it's on 0, 0 coordinates, which doesn't really fit into our existing 3D model, but no problem. You can see all the coordinates are 0. That's why we added the transformation tool. So here I will input the coordinates of our location, and the castle gets transported there immediately, and it's rotated wrongly, so I will also rotate it around the omega axis, and now it fits. A bit of a correction on the height, and position it a bit more back and left and right, and there it is. That's how our new castle would look like. See? But that's just a speculative scenario, so nothing will happen to our existing castle, which is pretty nice. But you could do this in 3Dsurvey without any physical equipment. Another thing I would like to show you on this case is you can do contour lines, which, if I may say, are in the process of improvement, but that's all I'll say. Soon they will be much more pretty. And it is generated really quickly on 0.5 meter equidistance, and that's the way we can visualize them in 3Dsurvey. All the pathways now are even better visible, see? And we can export them in DXF, in 3D or 2D. Okay. This was the first video, the first part of the possibilities for LiDAR point clouds in 3Dsurvey. The second one will be a bit different. So if we saw now what you can do without equipment, the second one focuses on what you can do with scanner point clouds. And I have just a quick warning here. I forgot to mute the music on this one, so hold tight. It might be a bit loud. Yeah, tune it down. Okay, ready?
It's right on time. We need to wake up. It's already 1 hour, you know, so let's make it.
Okay, everybody. Hope that wasn't too loud. I'm giving my word back to Marco now. If you have any specific questions regarding the LiDAR data or scan module, write them in the question box. We'll try to get to you later.
Okay, this was attractive. We hear you a bit, but yes, the music was great. Okay, so Zupan, Mattia finish with the LiDAR, point cloud processing explanation. Of course, there is much more. Probably you get idea what it is. It's just a 3D survey. It's a strong point. You can put a lot of different data inside and then manipulate it different way and edit it, join it, merge it, everything like that. So we're closing the point number 4 and starting with a point number 5, our last one in this webinar. Very interesting one. Volume calculations, all possible scenarios and everything what comes with this. And first we have a look the simple one, volume calculation, the single surface. But nevertheless, you have two options here. One is a simple selection, calculate volumes, or the second one, where you duplicate the point cloud, delete the area, and create a new surface, and you actually have more control. You see which is lower surface, which is upper surface, and so on. So this is point one. Secondly, we will see the calculation based on two surfaces from one of our customers. Then we'll see the option how to design new surface in 3Dsurvey. And I will link you to a YouTube video or webinar video about how you can import surface from third-party software like AutoCAD or something like that. You can directly import in a 3Dsurvey also. Design surface in AutoCAD and put it in 3Dsurvey. Okay, very good. Let's start with my first example. Here you already see this construction site. It's already classified nicely. And what's the most important to know with the volume calculation is we always advise you to calculate volumes based on a regular grid mesh. Okay, this is super important to know. So calculate the volumes based on regular grid mesh or DSM. Don't use it the full 3D mesh, because with full 3D mesh, which is the second option, can be super tricky if you have some kind of balloons inside or like a cave areas or something like that. You will get fully wrong number of volumes. So we motivate you, set the first option for volume calculation, regular grid mesh. It's also the fastest way to calculate it. I already classified this point cloud before. And when you do the volume calculation, go to grid cell size to 0.5, or if you would really like to be very detailed, very picky, to 0.2. But don't take it if you have an area kilometer per kilometers, take 0.5, otherwise you would need 128 gigabyte of memory. Smoothing cell size 1 cell or 0 cell, because you don't want to lose too much detail. Optimize this all and just click calculate. And the DSM or regular grid mesh is calculated super quickly. It looks like so. If I also turn triangles, so those are no triangles with a half meter size. And the fastest way, if you have that kind of stockpile here, is just selecting your area of interest. When you do the selection, take care what you select, because the lower surface will actually being calculated based on the boundary of your selection. Okay, so here is pretty flat, it's not a problem. You see I'm using the deselect tool also to correct my selection a bit. Okay, so you can play with this as much you like that. And nevertheless, let's leave this part here like so, that it goes like here up, that we see the mistake. When I select my area of interest and calculate and click calculate volume, this is the simple way of the selection. The lower surface will be interpolated surface. The upper one is the selection surface. And let's calculate the volume. We see here 4,244 cubic meters of fill, a bit of cut, total area, 3D area, 2D area, everything like that. I just confirm it. I see it like so. And this is the fastest way, maybe not the best one, because the lower surface, you can see it here, but it's not so nicely visible. So I didn't select here maybe enough, and that's why it's not connected here straightforward. But I did this on purpose. And if I go to volume, I can see this volume again here, and I can move with my mouse here, and I can see before surface, after surface, and fill and cut values. So in this case, actually, we see 10 meters of fill material before surface on height and everything like that. Okay, so this is one quick way to calculate out the volume of a standard stockpile, the most easy one. Let's clear the selection and show you the second approach of the same scenarios. So let's say here we have our first surface. I can rename it. I can go back, and the same way I selected before, I select this on point cloud. Before I delete this, I will duplicate my point cloud. So I right mouse click on a point cloud, and select, oh, not actually right, but I have here duplicate function. So what I'm doing now, I'm just making a copy of my point cloud, because I will delete some points out of it and I would like to keep the original one. Okay, couple of seconds to copy those 70 million points, something like that. So here is my copy. On this one, I will delete the selected points, delete selection. Okay, hard for my computer right now. Okay, and now we have a hole in the point cloud, and I will go and go again, mesh, regular grid mesh, same parameters, and I will now actually prepare me my second one to have better control. So if someone asks me, okay, which was your upper surface, which was your lower surface, now I can go inside and see. I can even colorize it. So let's make the lower surface green and the upper one realistic. Okay, and now I can exactly see also with the bounding box. So sometimes, now this is the easy scenarios, but sometimes it's kind of super difficult to see small part of the vegetation or side or anything like that. And in this way, I can really see what is actually my volume. So let me play a bit with the bounding box. I'm using the right mouse. If I'm using the control button and right mouse click, I can slide down my stockpile and always see here actually the upper and lower surface really nicely. So in this way you can visualize you perfectly and you see where two surfaces are going together. And now it's also not so important where I actually select my area of interest. Even if I go over this one, shouldn't be anything wrong because the surfaces here are fully equal. But nevertheless, let's calculate it just for this part. Okay, calculate volume and everything else. So now we have the first surface. I can also switch because I know my first surface is actually upper surface, and the second is first. So you can also switch here. Then the cut and fill values are also right one. And in this way, I should get pretty similar results. There is a minimum difference because I select now correctly the complete stockpile, and here we have the volume. So in this approach,
so this is more accurate.
It's big difference because I didn't select this part here. Okay, so it's accurate the same, but now you exactly know which is your upper and which is your lower surface. And when you save the projects, you always have this also saved. So it's just the safer way to calculate all volumes.
And okay, it's better to visualize.
And it's also better to visualize, as you saw it before. Okay, so let's go to volumes, the same options here, just deselect to continue on my working. Okay, let's continue on first mesh. Now another option is you can design new surfaces. So there are a number of functions here. So let's say I have here a plane or something like that, and I would like to flatten this one, and I will like to set height to or increase height to plus 5 meters or something like that. I can easily do it. Okay, and create a new surface. So when I have something like that, I can make it maybe kind of more fluently with flatten in a way like that. So you can play with this limitless, okay, and create your design surfaces for the new volumes. Or if you need to calculate surface from specific height, you can go back to point cloud. I will take this modified point cloud already. I will give my height here, so 286, for example. if you need to calculate volume from some specific plane and realistic surface, select all your points, set height to, let's say 290 height, and immediately move all the points to specific plane, like you see it here. And again, mesh, regular grid mesh, same parameters, and now I can play with those two. So I have some plane which is cutting off my surface, as you can see it here, and I can calculate free volume, how much material you can put in some stockpile or hole or anything like that. Okay, I'm a bit rushing because of a long time. Another option is that you create your new service based on CAD data. Okay, so let me turn off the point cloud. I have mesh here, like that. I go to CAD, and I can take, let's say, a few points, which I measured with the GNSS device. Even I could add some break lines in my data or something like that. If you have actually manually measured stockpile 2 years ago with your total station device or GNSS device, even if you have that kind of points, you can use the mesh algorithm, so triangulate mesh from CAD data, calculate the surface out of it with break lines and everything. Important, no, this is a full 3D mesh. We have a special trick here to convert it as a regular grid mesh. Right mouse click and convert to point cloud, 100 points per square meters. And this is now actually the point cloud. And then, based on this point cloud, calculate a regular grid mesh with the same parameters. And now you have a regular grid mesh with this data. Okay? And calculate it out of it. Okay, this was part of it. Not to spend too many time because we are low with time. What I would like to show you, the fourth option, AutoCAD surface in 3Dsurvey. Go to our 3Dsurvey webpage, in search, write AutoCAD. The first webinar which pops up is step-by-step how to import 3Dsurvey point cloud, meshes and everything from AutoCAD to 3Dsurvey. Check out this one and you will find also a lot of interesting tips and tricks inside of this one. Okay? Oh, let me see, where are we currently? I think we came till the end.
Yeah,
With this
Marco,
one,
do you know what we missed about volumes? Some people would like to change the color, you know, of the point cloud.
Do you have something ready or should I do it?
Yeah, you can do it or I can. It doesn't matter.
Well, feel free to rest a bit.
Okay. Okay, so I can show you on my screen. So when you have a volume like this, maybe you don't like the colors so much, you can go to the volume tab, and here you have all the possibilities to change these colors. So basically there are 4 colors for maximum cut and minimum cut, and the same for fill. So you can simply double click on the color box and change it. So maybe you want to go from green to purple, and from orange to confirm it, from orange to light magenta. That's debatable if that looks better, but it's different if that's what you want. And one last thing I would like to add regarding the volumes is this nice hover over info box. If you move over the volume that's visualized like this, you can see how much there is fill exactly at that point, and where was the height before and where it is after. So if we go on top of that pile, we can see there's a fill of 2 meters, and behind it there's a little cut, well, of just 6 centimeters. But that's very informative info box. Okay, that's what I had to add.
Thank you, Mattia. So I just forgot a small part before we finish with the volumes one. I have a nice example from our customers where he fly 2 flights on the different days for the same site. So just a quickly overview how it looks like, something like that. Can you see my screen?
Yes.
Okay, very good. So here we have actually 2 scenarios. This is the first surface when there was a parking slot or something like that. The point clouds is already classified and filled and polished for the volume calculation. This is already the surface. Then we have a second measurements where they grab a lot of material away. Probably some hotel was built there. Then the third option was actually design surface based on a specific height. We can see it here, 28. And actually, they also import a CAD boundary, so you can select your area of interest for volume calculation also based on CAD data. You can draw it in 3Dsurvey or you just import it. And right now I have my first plane, second plane, and based on this, you can calculate out the volume. And here we can see the volume actually from the 2 surfaces calculated in 3Dsurvey. So pretty nicely visualized everything and super accurate at the end. So I would just like to say there's no other technology that can do this job so nicely that this, okay? And beside, of course, you get also an orthophoto. So this is kind of a starting point. Okay, let me turn off the mesh, the CAD data, to not see it. So this was the starting point. I also need to turn off the volume. So this was the starting point, and then this was the end point.
Marco, now that you were going through all of these things, one thing we could mention also is you can simply generate a report on your project, like measurement report. It will include all your volumes, your profile lines, or not all, just those that you select. And you can represent them on a chosen orthophoto.
Exactly.
It's really quick.
So it's generated doc file. Let me try to open this one. And you should have the main important information inside. So where's your volume calculation area, imported fill and cut materials, the profile lines where you calculate them, drawn profile lines, and everything like that. Thank you for remembering me this. Okay, so we are quite exhausted already. 1 hour and a half webinar should be half shorter, but a lot of interesting things to show with you, to share with you, and we still have a lot of questions. So for the ones who will stay longer, we will now start to answer those questions one by one, maybe limit it a bit. Let's take another 15 minutes. To answer them. For all others who are already exhausted and you leave it, you can watch the recording if you're interested also.
And thanks for coming.
Yes, definitely. Thanks for coming to our last webinar in December. See you then in 225, okay?
Okay, but for those who are really high with energy, we can go through these questions. Okay, Marco, I'll read them and you can quickly answer.
Very good.
So this one can be really quick or really long. So how to improve mesh quality on true orthophoto? So it's a classic one.
It's easy one, so capture images from as much as possible different perspectives. So in meantime, I can load in one nice project we did with, let's say, one house captured with 500 images, and these give you the perfect mesh, okay?
Maybe
And
not to
yeah.
be too long, that's the topic that we had on the previous webinar also.
Yes, good one, Mattia. Check it out. Yes, go to our webpage. Do you see my screen now?
Yeah.
Okay, under the webinars. Okay, under the webinars, check out this webinar. So the fastest way to create professional 3D model, and you will know everything about it. Okay?
Yeah. So the next question is from Mikhail. Is it possible to combine LiDAR data with classic image? What workflow can be used? Pros and cons. So yes, it's quite a good question. It is possible. Marco, do you want to explain further? Do you have a nice example maybe?
I'm not sure. It would take too much time. I would just say yes, it's possible. That's why we prepared all these additional tools. So you can have a LiDAR point cloud from terrestrial scanner or from a SLAM device. And if you align this data with the photogrammetry, you can use the images from photogrammetry to texturize the LiDAR mesh actually. Okay, so this is possible. It's not a problem. Easy to do it. We can also help you via email if you need it. Not a problem.
Yeah, and if you're using RTK drone or ground control points, you can combine your photogrammetry point clouds with your national available LiDAR data. People do it all the time, so it works really well. So then we have another question. Is it possible to extract a world file of a specific original nadir photo?
So
I don't think photos have
no.
world file. They just have EXIF data about their telemetry.
Yes, exactly. So you can save an orthophoto and you get a Word file from the orthophoto, but not from image. So image can have a center position. You can export this one if you go under the camera parameters. So data, export camera parameters, you get the position of specific camera angle and everything. If you mean that, you have it, but I'm not aware that this can have a text Word file or something like that.
So there was a question from Julia. Are the coordinates accurate? I'm not sure on what part of our webinar this was question was posed, but short answer is yes. Right, Marco?
Exactly. If you do by procedure as it should be done, it should be accurate up to 4 centimeters if you fly on 80 meters with standard drones.
Okay, Marco, one that you can show us real quick is how to filter nadir photos. So,
very nice, very nice one. So
combination.
let me open this example.
So this is in case you have nadir photos and oblique photos in one project.
So in this case, the best approach is you start with everything, and then just before the last step to calculating all the true orthophoto, you go back to image tab, you take a sparse point cloud. By default, they are all on. Toggle text off that you can see, and just take the button deselect, left mouse, left mouse, left mouse, left mouse, left mouse, right mouse, and now those all side photos are deselected. They are also deselected here. You could do it also like that, more options, but with deselect button here, it's actually super easy. And now for the orthophoto calculation, just the nadir images were taken.
Yes, thank you, Marco. Something I forgot to actually show. So Blago commented that these look very handy. How can I export the lines in CAD? So that was probably when I was showing CAD stuff. It's really simple. So Marco, if you have anything drawn in the CAD.
I'm just preparing this, so nothing special. Just go under the data, save CAD as, and take the DXF file. By default is DXF, and that's it. And save it.
Really simple. Thank you.
Yes.
Okay. So next question from Addis is, did you draw solar models in the CAD option? How can this be done? Well, Marco, perhaps you've seen this.
You're the expert. You're the expert for solar.
I'm not sure if I can answer this one because I was using a certain feature that's not yet available, but is under development. So this may be a hint. It was done in 3Dsurvey, but I had a little help of a feature that's coming out, and it's going to be really great for jobs like this. Because you may have noticed that those panels were drawn really perpendicularly, and that's
on a
kind of
plane
hard.
or something like that, huh?
Yeah,
let's keep it a bit secret for another webinar.
Should be a nice new year, right? Or next year. Okay, that's all we should share so far. Okay, then there's Blaž. It's a bit of a story. I draw a polyline with points on vertices. If I later edit the polyline, it will only move the polyline vertex, but the points stay on the old location. Yes. Is there a way to lock the points so they would move together with polyline? That's a good suggestion, Blaž.
That's
Marco,
good. It's currently not possible because those are two separated elements, and when you edit just a line, and the points are staying there. That's true. We know this one, so this is for future work, how to combine them, how to connect them. But yes, you're fully right. We know this one. So you also need to move the points. Okay.
Yeah. So Ahmed is asking if he could get the PowerPoint from this webinar. Maybe contact
or
Ahmed.
you have the Okay, send us please the email and we will reply it.
Okay. And there's another question from Blaž. Sometimes I get 2-point clouds of terrain on the 2 separate height levels instead of one single point cloud. I suspect something is wrong with my flying path.
So if those are different flights, usually there can be 2 problems. So the first issue is your drone GNSS or drone GPS. So it's always great to have at least one GCP point to align this, because if you fly without GCP points, it can be 10 to 30 centimeters off. And another one is sometimes the camera parameters are not calculated perfectly. What could help you with this when you fly a single grid mission, use the option in DJI optimize elevation, something like that is there, and this can improve it.
Okay, thank you, Marco.
Accuracy.
Yeah, possibilities. So we have only 3 more questions and then we're done. Is it possible to georeference LiDAR point clouds in 3Dsurvey using ground control points?
Yes, it's possible. So you just use the manual registration approach. You need to have a scan model for this, and you actually show points on a point cloud and show on which point you would like to attach. You need at least 3 of them, and that's it.
Okay, thank you. Then, can I upload a file with reference point clouds when creating an orthophoto plan for more accurate coordinates? I'm not sure. Marco,
Can
do
I
you
upload a
understand
file
the question?
No, I don't understand. So just a second. Can I upload a file with reference points when creating an orthophoto?
So ground control points, maybe
Maybe
measured
ground
on the
control
field.
points, but this is the ground control points are used before. Yes, we get, so we get the confirmation.
Yeah.
So ground control points, yes. So when you do the orthophoto calculation, first step of the processing is bundle adjustment. The second one is orientation. And you do the orientation with ground control points. And of course, this improves the accuracy. And then also the orthophoto is the same accurate as ground control points.
Yeah, so definitely yes. Thank you, Julia, for the question. And there, I think this is the last one. Is there an option to snap points to other existing lines or points in X-ray view? Question from Maya. Well, that's also a feedback that we got from when releasing the scan module. I think we can say that this is something we're working on.
So
And
it definitely will be in the next version. So
yes,
all additional snappers will be available also in X-ray views. So you will have this option in future.
okay. Oh, another question came. Is there a way to orientate the LiDAR dataset? Well, we kind of answered that already. And the answer is yes. You need a scan module for this one.
Yeah, or the second option is also transform tool. So maybe not so user friendly, but if you go on a point cloud rise mouse click transform, you can enter the parameters, offset parameters or rotation parameters, and even scale or something like that, and confirm it, and that's it. So depends what you would like to do, but there is option.
Okay. Well, this is it regarding the questions. So thank you all for the nice comments, and thank you all for coming. Marco, do you have any closing thoughts?
No, thank you for your patience.
It's been a long one.
Yeah, it's been a long webinar, but super interesting. Hopefully, you liked the webinar. It was great to host you today, and just wish you a great December. Enjoy this happy time, and see you on the next webinar sometimes in 2025. Okay.
Until next time, happy holidays. Enjoy the new year and everything.
See you. Bye bye. Thank you for coming. Bye.
Bye bye.